Probably should turn the mic on. Good morning, everybody. Welcome to the morning show here at Master the NEC and sponsored by Electrical Code Academy Incorporated. We're going to do this show every morning at 8 a.m. Eastern Time, unless, of course, I have to miss a show for some other reason. But that's where we're going to be here in the mornings at 8 a.m. And this is something that it wasn't going to start until next year, but I figured, what the hey, let's go on and get started a little early. It's some of the things that I promised for people with the move to Virginia from our Texas office. It's very early, so it's not really convenient for those that are out on the West Coast, I guess. But welcome to the morning. We're going to call it the morning drive, the morning show. And you never know what we're going to talk about, but today I got a great one for you because today on the coffee hour, we're going to be looking at motor circuits and we're going to be breaking it down. And we're really going to be kind of looking at the program that is our commercial program. So a lot of people have asked about the commercial programs. So this is kind of giving you an idea of what is part of your commercial wiring program that we have. So we're going to do a little lesson, look at little motor circuits today. Of course, if you have any questions, feel free to post them. We are streaming on YouTube and we are streaming on our own proprietary platform, which is where we're going to have all of our webinars in the future. So if you haven't tried it out, do me a favor, give it a test drive. Let me know what you think over on fasttrackstube.com. And if that's where you're watching now, give me a shout out here. Also, since we're doing coffee hour, I've got my blend of coffee. It's the Dunkin' Donuts K-Cups. Okay, nothing fancy here. But we will be featuring our own proprietary blend in future episodes that we have once that gets shipped to us from the roaster. So we do introduce that. It is available on the website. We have to order it the same way you do. So if you're interested in that, but it is costly. So anyway, thanks for joining me this morning. Give a shout out. Let me know where you're from, where you're listening from, and if you're in our programs or not, or you're just joining in from anywhere. If you randomly stumbled across this, get used to it. We're going to be doing this in the morning, so make this part of your daily routine, and we'd love to have you here. And if you've had topics that you want us to talk about when it comes to electrical in some form or fashion, please, by all means, feel free to let us know. Okay. What is up, Ron Bow, my brother from another mother? Welcome to the show. You're up early today out there, as I know you always are up early and at it. So again, welcome to the show, watching over on the YouTube channel. Okay. All right. Let's go on and take a quick look at what we're going to be talking about today. Oh, I should say this show is sponsored by Electrical Code Academy. Obviously, it's the very first of the morning shows. So make sure that you, again, bookmark it and share it with other people. It's early. Okay, it is early. This is a live show. Good morning, Edgar. All the way out. Dude, really? California? This early? Wow. You know what? You are somebody that buys into the understanding that if you sleep till late in California or the normal time you get up, you're already behind, right? Because they're already going on the East Coast, so I get it. Good morning to you, and thanks for joining me. All right, so we want to make this morning show whatever you want it to be moving forward. And so if you have questions, you have things you want us to talk about, by all means, feel free to bring them up, and we're more than happy to talk about it. The show is for you, but we're going to kind of try to do some kind of little lesson every morning in order to get your day going. So let's go on and look real quick over at the lesson for today. So check out this schematic, this layout here. So this can be a nightmare for people, right? If you're not familiar with how motors work and all the little pieces that are associated with it, it can be a nightmare for somebody. Now, for me, I look at this and I say, you know what? I could break this thing down to all different types of ways, okay? All different types. What's up, Red Dog? Welcome. Good morning. Thank you for joining me. All you early risers out here. Appreciate it. Seems like the consensus is that everybody's on the YouTube channel. and nobody's trying out our new platform over on our Fast Tracks tube. Check it out. That's where I will be holding our webinars in the future. So I'll make sure you at least get familiar with that platform. So let us know. All right, so if I'm looking at this thing and I'm an electrician and I've been handed this thing, of course, this one's easier because it's already given you all the stuff. And maybe in a future morning episode, I'll do some schematics where I don't give you the info and we can work it out, that type of thing. We'll work this one. We'll look at it a little bit. But whereas I wanted to show you this one, this is actually directly out of, believe it or not, this is actually out of the commercial wiring program that we have. So also, I'm gonna try not to sell you. I use our information to be able to do the lessons. So again, I kind of gotta reference it because it's part of our program. But so check this out. So when I'm thinking about a circuit and I'm being asked to do motors, for example, I'm looking at this scenario right here, and I try to treat each one of these separate, right? That's my goal. So this is one set. I'm not even worried about the feeder. I'm not worried about any of this yet. I try to, when I'm sizing or I'm designing something, I try to look at this first and then this first. Now, what is interesting about this layout is that we've got not only circuit breakers involved in it right here, but we also have fuses involved in it. So this makes for a good something to review because this has a little bit of both involved in it. And not only does that, but it has our overloads here. And also we've got our conductors down here that are going from the overload down to the actual motor. This is a 20 horsepower. Obviously it's 3-phase. That should go without saying because they're all on a breaker, right? Should go without saying. Hopefully I ain't got to say that yet. But hey, if I do, that's okay. Not a problem. But as you can see, this is one big long feeder, and these are tapping off of it to do multiple motors. So we can kind of look at how each piece of this is calculated out. So let's say I want to do this string right here first, right here, this one on the left here. So one of the first things that I would have to do typically, or I tell students to do all the time is we gotta get the info on that motor. So I'm sure the motor has a nameplate, which we all know that you need this nameplate in order to be able to size the overloads, right? That's 430.32, right? And then, of course, we know that when we're sizing the short circuit ground fault protection, that's this right here, that we're going to be doing this based on what? 430.52, okay? So that's what we'll be doing here, right? And then we need to know what the motor's FLC is. All right, when we see FLC, there's another slang term that we use, and that is FLA. And FLA, just kind of think about, that's the amps on the nameplate. FLA, think nameplate amps versus FLC, which is what's in the NEC. Interesting about that is, why do we always use the FLC for most of the stuff, like the wire sizing, short circuit ground fault protection side? Why do we do that? Because the FLC is a fixed number. So it's kind of like a worst case scenario. So if somebody comes and changes this motor, and maybe it's even a more efficient motor as time goes on, if we traditionally size everything based on the FLC, then we know that we're going to be okay, and that conductors are going to be sized more conservative than they would be possibly for something like an FLA, which is on a nameplate, which can change for the motor. Why? Because it has to do with power factors and all kinds of things can affect the FLA, but the FLC is constant. And so that means that if we're sizing things that are on that constant, then it's going to be pretty consistent. If we go down the road and Ronbo decides he wants to change a motor, and the system's been in. I know Ronbo does a lot of work in locations where there's a lot of existing stuff. So he comes out there and he replaces this motor, right? If he replaces a 20 horsepower motor that's a little more efficient, it's less amps, right? Reality, it's less. It's already been sized to the 20. So since they're using a base value in the FLC, he doesn't have to worry about it. It's still going to be okay. And if the motor actually draws less, who cares, right? You sized for the worst case scenario. So that's a good thing about the NEC is it kind of keeps you grounded in the fact that we're sizing this motor and it's going to stay consistent. Even if the motor changes, it's still 20 horsepower motor, still going to be following the same rules, that type of thing. Now, we like to double check all these things. Again, don't take anything for gospel. I always say this. So this right here happens to say that this 20 horsepower motor under 430.250, which is a table you should be using for a three-phase motor, it states that it is 59.4 amps, right? 59.4 amps. Okay, so we'll verify this. Let's go do this. So Nick, what is it? Ronbo, there you go. Great topic. I need this area of the code. Absolutely. I'm sure you do a lot of motor work, a lot of well pumps, pull things up and things like that. So motors are always a topic that people seem to struggle with. And motors can get really deep. But I tell people, you know what? You don't need to memorize all that stuff. As long as you understand the core fundamentals, then you'll be okay. Single motors, understand 430.22. You'll be good to go. If you have multiple motors like we're going to look at today, then you need to make sure you understand 430.24 because that's multiple motors. And we got multiple motors here, that type of thing. So as long as you can understand the basic concepts, overloads, as long as you realize that for the most part, most of the motor overloads are going to be, dealing purely with 430.32. If you know how to do the pieces, then everything else you can just learn and add to it, right? So in this case right here, let's go on and look in the NEC. So I'll go into the NEC. And first thing before we look at, obviously I was geared up to look at your servo motors because that's what we have. Let's go on and look at and just double check our ratings on our motors real quick. Let's see, FLCs. So let's go on down here and we got to go to 250, right? Because that's the three-phase one. Let's see if we can't see the whole thing. Okay, we got pretty much the whole thing. Not all of it, but you can see enough of it. So in this case, I believe it was a 20 horsepower, and it was, I believe, in this case, I think we're going to say that this is, hold on here. We're going to say this is, we're going to say what motor size are we going to say, just for our craps and giggles for us today. We're going to say this is a 208. Okay, so it's a 208Y. Right? That's what we're going to be using. So let's go here. So this is 208 right here. Here's the 208. And we'll come down to the 20 horsepower right here. Obviously, if you're practicing motors and you want to put together some configurations of motors and all, change it up a little bit. Change the different systems, change the horsepower, all those things. And people ask me all the time, for example, those that are practicing, they go, can you give me a motor question with 15 horsepower or 25? I'm like, you only need one example, and then you can change the variables if you want, right? In order to get a better understanding. So here we're just looking at, and we're at the 208, and we come straight down here, and the 20 horsepower is 59.4. 59.4. So I think in our example, that's what we had right here, 59.4. So that one's accurate. Now, as I always say to folks, I'm not going to waste my damn time. I'm already here, so I'm going to go on and double check the 50 horsepower while I'm at it. Okay, so since I am here, there's the 50, and I'm going to go over, and I know that it's in the same column, 208, right here, right? And so it is 59.4, okay? So there you go. So I've got 59.4. So 59.4 is for this one. And for the 50 right here is 143. All right. So we're good to go there. So that's accurate. These are all accurate. Okay. All right. So let's just do some calculations. Let's do some pieces real quick since we have that info. All right. So we're going to size. This is a circuit breaker. So what is the rules for the circuit breaker? Well, we can come down here and look and see what the rules would be for the circuit breaker, all right? And so let's see, we could pop all this out, but let's go on and do the code. So we're doing this one string right here. So let's go to the code. And let's see if I can share it right here. So we're going to do this one string. So where do you go for sizing the short circuit ground fault protection? Again, this is just the simple circuit. This isn't the whole feeder. This is just that one leg, keeping it simple. All right, we'll go right here, and we got to go to this table. I'll pop this thing out for you so you can see it. So this is our table 430.52. This is the maximum. That's important to realize that this is a maximum. Can you be less than this? Yes. In other words, if it says inverse time breaker 250%, can I be less than that? You can if you would like. Okay, this is a maximum rating. So in this case, we have a 3-phase motor, all right? Polyphase motor here. But good news is it wouldn't matter whether it's a squirrel cage, other than design B. We didn't say it was a design B. Either way, in this case, all of these are 250%, right? So that's consistent with all of them. So we'll go back here. All right, so remember what we said? This was 59.4 amps, right? So let's pull out the old trusty calculator. I have had this calculator for damn near a decade. So it's very trusty. It's battery powered and it's solar. So that's what I always recommend if you're going to take an exam. Don't trust it. My luck, Murphy's Law, you get in an exam or something like that, and what happens? Damn calculator dies on you. And are the people very helpful for you? Probably not in there, you know. So 59.4 times 2.50 is 148.5. Right? Well, me and you both know that this. Why is this 150? Well, if we go back over here to the code, right, you'll see that this is the maximum, right? But one thing to look at is right here. See this little note right here, this number 2 right here? Call it a note, whatever you want to call it. Right here, this 2, right? Because you're saying, wait, Paul, this said maximum. You can't exceed 250%. Ah, okay, but you got that little 2. What does that 2 say? Well, let's come back down here and look at 2. 2, okay? It's got a little 2 on there. Let's see here. Boom. Okay. So the volumes given in the last column also cover the ratings of non-adjustable inverse time of circuit breakers. Okay. Got all that information. But what else do we have? All right. Well, we have other statements underneath this table. We got more. We got to go down and read more. All right. So how about this? These are very much applicable. Oh, by the way, I am in the 2023 edition. I should probably make that clear because if some of you out there following in other editions, you see all this damn yellow here and you're like, what the hell is going on? But remember, all of this stuff right here is applicable to the table. It's applicable to the rule, right? And also, you notice that it says the protective device rating shall not exceed the value calculated according to the values given in table 430.52C1. That's this table, which is, again, you don't exceed the 250%, right? Okay. But always remember these little notes. I'm just kind of pointing those out now because you do have notes that are applicable, right? But what's really important to us is you see all this grayed out language. It's been added to make it very clear in the 2023. It also goes, unless otherwise permitted in 430.52C1A or C1B. Well, what does C1A say right here? It says, where the values determined in table 430.52C1 do not correspond with a standard ampere rating and setting provided in 240.6. And remember, 240.6 is what? That's the list of the different standard size overcurrent protective devices. And I can promise you in our situation, the 148.5 is not standardized, okay? So in this scenario, we're allowed to go what? Up to the next higher standard rating or setting shall be permitted, okay? So what's the next standard size over a 148.5? 150, right? So folks also say all the time with me, they go, are you sure? Are you sure that's what it says? So we'll go look at it. So 240.6, just so you can see the standard sizes. Here's the standard sizes. And you see that there's 125, and then it jumps to 150. So the 148.5, obviously, this is going to allow me to go to the next standard size. So back to our drawing here, this is why this is 150, right? That's why that is 150. All right, so now let's kind of move down the line real quick. And again, same concept on this string here. The only difference is going to be that this is using fuses. It's the only difference. And fuses aren't at 250%. They're at their own rating. But we'll look at an overview of everything, okay, for this morning coffee hour. All right, so let's do the overloads and get them over with. So the overload is based on the nameplate. Where does it say that in the NEC? Well, that's going to be at 430.32. Okay. So and these are things, you know, that you can just kind of cement into memory. Oh, by the way, if you happen to get lost in any of this, I want to share the fact that you should never forget that you have this nifty in the front of your in the front of 430. You have this nifty thing that's going to get you pushed right back into where you need to be. For example, since we're now shifting and talking about the overload protection. Okay, so you've got all this information here. And here, motor overload protection, which is in part 3. Or then you could go up here, right? And you could find part 3. And you can see that it says motor or branch circuit overload protection. It starts at section 31 of Article 430. And it goes all the way to 44, depending on what you're working with. Okay, so don't forget, and if you get to motors and you freak out, this is a great chart because this allows you to visually see where you need to be in the code. So in our case, we're going to jump all the way down to, all right, so we're going to part 3, where we need to be, and we're doing overload protection. So it starts at 31, which is the general information. And then, of course, we're here. And remember, all motors are continuous duty until stated otherwise. Now, we're not talking exam prep this morning. We're just talking in the field. So just be aware that you look at your motor, find out what it is. But generally, I would say most of the motors that we deal with are going to be continuous duty motor. That's different than continuous use, kind of that you would see with 3 hours or more at maximum output, that definition in the code. This is continuous duty motors, but for all intents and purposes, essentially treated the same way, okay? 125% when sizing anything. All right, so, but we're talking overloads, so that's a little different. So when we come down here, overloads, okay. So in our drawing, that was a whole separate overload device, okay? And so we look down at it and we say, okay, well, obviously we're right here. That's a separate overload. But one thing to remember is you may have a motor with a thermal protector or electronically protected, and you have it's integral into the motor. Then you have this information. It's just same thing. It's just different percentages. So it's not brain surgery. It depends on the motor that you have. Now, in our example, nothing said that it was thermally protected or electronically protected. And of course, in our diagram, it's totally separate. So makes sense, right? But you have rules for when it's integral into the motor. And you have for 1 horsepower or less, automatically started. And again, you just have to read the rules. And then, of course, you have C with selection of overload devices. When the standard ones, or the ones that we're going to talk about, are not sufficient, then the code says, okay, well, you know what? I'll let you go to a different percentage if you size that overload and it's not sufficient for that motor to start and it keeps tripping the motor. So you always want to start up here in A1, okay, separate overload. You'll start here. If that is not sufficient, or if the question, if you're on an exam and it kind of says it's not adequate for the motor to start, it keeps tripping the overloads, then you get to jump down here to C and use these percentages. So nothing for our motor yet we determined is going to be causing it to trip off. So we're going to be using the standard values right here, okay? So we're going to be in this table. And I'll pop this out so you can see. So this is what we'll be working with. Now, in our motor, we have to have some values to work with in order to know whether or not we're going to apply 125% or we're going to be using a 115%. So interesting. If the service factor on a motor, marked service factor, is 1.15 or greater, it doesn't matter what the temperature rise is. It's if the motor's service factor on the nameplate is stamped 1.15 or greater, then you're going to be taking that value from the from the nameplate, and you'll be multiplying it by this modifier, okay, 125%. If the service factor is not greater or it's less than 1.15, but the temperature rise is 40 degrees C or less, regardless of what the service factor is, then you're going to be doing it at 125%. So one of the big misconceptions when it comes to overloads is that you have to meet both of these. No, you have to, any one of them will trigger it, that type of thing, okay? And then for all other motors, then it's going to be just 115%. So for example, it is a 1.14 service factor, which is less than 1.15. And the motor temperature rise is 42 degrees C, okay? Then none of these two right here apply. Then it would be this one, 115. If they don't tell me anything, and on an exam they got to tell you, but in the real world, you're really going to look at it, and you're only going to go to all other motors if neither one of these apply. But if either one of these apply to your overload or to your motor situation, then you have to apply it at 125%. Okay. So in our case, let's go back to here. All right. For this case, for ours, we're looking at, let's see here, 55 amps is on the nameplate. Okay. And this type of thing. And we don't, because we're already given a nameplate value, that type of thing. And where we're given this in the lesson is that up here in the lesson, it gives you different values. So temperature ratings of the motors, and it gives you all the information you need, and it automatically tells you what to use, okay? So again, at the end of the day, you're just following along at what it tells you to use. But for me and you, in real world scenarios, you must pay attention to whatever the nameplate says and whether or not those service factors are in play or whether or not the temperature rise is in play. Okay. So in our case, just for our example today, we're going to say that the service factor is higher than 1.15. So we're going to be using the 125%. So how do we do that? Again, your motor may be different. In this case right here, 68.8, where do we get that? Well, we have to do what it says. So I'm going to take the 55 times 1.25, and that is 68.75. Okay, so again, 0.75, we're going to round that to what? 68.8. Okay, and that is what we're going to do for the heater, or we say the overload. And that's how we size that one. Okay, pretty straightforward, right? Also, I'll remind you that if you happen to be in our, you have our commercial program, you will see that it also, and I'll just pop this out over here on the right, it will break out for you everything. So it's, it lets you see how we size the conductors and everything. So you're never left hanging, okay? Never left hanging on anything. Just wanted to make sure you see how this is broken out. In case you're saying, well, I need a detailed list of how this is broken out. It's all right here. Okay? It's all in here for you. Okay. Let's kind of go through the pieces here again. Okay, so that's done. Now, sizing this conductor. Now, remember, this is to one motor, right? And what we're going to do is we're going to size now. We've done this. We've done this. Now we're going to knock out these conductors, okay? Now, as you can see here, the branch circuit conductors, we're sizing this because this is one string, okay? One layout to one motor. We're not even dealing with this yet, feeders. So what do? Okay, we take 430.22. It's a single motor. And we're going to do this at 125% of the FLC, right? So let's go on and do that. And where do we get that? I'll take you to the code, because I like to go to these different pieces of the code. So we're doing single motor right now. We're doing that one string. And here's where it says single motor. It says conductors that supply single motors used in a continuous duty application shall have an ampacity of not less than 125% of the motor's full load current rating, as determined in 430.6A1, or not less than that specified in 430.22A through G. So you have different things here, whether it's a DC motor, multi-speed motor, Y start, delta run, part winding motor. And then, of course, you have the other than continuous duty. This is what falls into things like periodic duty motors, intermittent duty motors, short time duty motors. Elevators are a great example of start, stop, those type of things. So that's where you would use this. Now, here's where it's interesting, though. For those applications, you're going to use the nameplate. See? It says the nameplate current for sizing those conductors. For us, since we're using the FLC, because we're a continuous duty motor, that's why we're using the FLC. But I just want people to remember that if you happen to have one of these unique motors down here, okay, in E, then you've got to shift that mind and say, well, I'm not using the FLC anymore. I'm actually using the nameplate value because of that unique motor, that type of thing, right? So just remember that in case you kind of get lost in your head somewhere, okay? So the majority of what you're going to do is continuous duty motors. Again, but just so you know, there are other types of motors, and you'll see there's other instructions here. So it's not like you have to make it brain surgery or make it difficult. You just go and read the area that causes you any question. Of course, as I'll say always, if you have any area that's confusing to you as you're going through our programs, and all you got to do is go to paulabernathy.com, literally cut and paste what you don't understand, paste it in there and send it to us, and we will answer any questions you have, that type of thing. Okay? That's what we're here for. All right, so let's go on and do this. So 125%. So let's go back here. All right, so we know that our motor is 59.4 amps for this one here, okay? So I'm going to do this real quick. So 59.4, that is our FLC times 1.25, and that is 74.25, okay? So the amps are at least 74.25. So in the NEC, all right, see, they picked a 4 gauge, okay? So let's see what we're dealing with. I'm going to go to 310/16. I'm going to get me some amps here, or some conductor sizes. 310/16. And here's where we're at. I'm going to blow this up for you so you can see it. Let me share this tab. Okay, so here we're at here. So it was 74.25. So we're coming down here, and it looks like, obviously, 6 is not going to work. So we're going to use the 85 amps or the 4 gauge, okay? Right? Now, some people will say, Paul, it's under 100 amps. It didn't really say conductor size. Why didn't you use the 70 under the 60 degree? Well, the reason for that is that typically your continuous duty motors, and it explains this, by the way, in the lesson when you're in the program. It explains why it uses the 75. But if you go look at 110.14c, you'll see that it talks about motors. In motors, you use the 75, okay? So that is why we automatically just go to the 75. Now, that brings us to an interesting topic when it comes to conductors. And I like to point out interesting stuff to everybody, that when you think about a conductor, if it is marked 75 degrees or higher, and even though when you're dealing with the 60-degree column, let's say for THHN, so you may have an ampacity that's less than 100 amps, and you've got conductors that's 14 through 1, and you typically would say, and if nothing's marked, I'm going to use the 60-degree column, and that would be true. However, if your lugs are marked 75, your wires at least 75, and typically it's not going to be 75, it's going to be 100. I mean, excuse me, a 90. I don't know where I got 100 from. Be 90. But as long as the lugs are rated at least 75, as long as the wires insulation is rated at least 75, and as the loads terminals are rated at least 75, even if the ampacity is under 100 amps, and typically you would fall in 6-degree column, you get to use the 75 because every component is rated. And that's also listed in 110.14c to allow you to do that. Now, does that apply the same thing to non-metallic sheath cable? Absolutely not. You can use the higher for adjustment and corrections, but again, absolutely not. But any other application, unless it states otherwise, most certainly can do that. Now, if I'm on an install and I have no clue what the terminals are rated at, I have no clue what the wire's rated at, then I'm obviously going to stay in the 60-degree column because it's under 100 amps. And I can obviously tell these conductors are going to end up being, in their cases, going to be what? It's going to be 14 through 1. But also remember, in ours, we already calculated and we said, okay, what size conductor are we going to need? So if we go back here, we determined that we needed 4 gauge, right? So let's go back to the lesson. So that's where this 4 came from, right here. Oops, let me get rid of this here. Right here, that's where the 4 gauge came from, right here. And again, straight on through, okay? And let's see here, just wanted to show you how the lesson works. I will blow this out as well so you can see it on the right. Just that piece, just that piece, that's all we're looking for. All right, so there, and this is the one we're doing, the 20 amp one, right? There was that 59.4 amps right here, and it might be hard for you to see, so I'll blow it up a little bit right there. So, and we did the branch circuit we did here at 59.4 times 125% is 174. We dropped the 0.2 because it's pointless, right? 0.5 or greater, we round up. Anything less than that, we're allowed to drop off in amps. So we're just going to use the 74. And we get all that from 430.22, right? Conductor sizing, you saw we just did it. We're using the 75 for that because it is a motor. And you kind of got to understand 110.14c. Makes it a little easier to grasp while we're using the 75. And then, of course, the overloads we did here at 125% because we said, and again, you see where it says options. It's great for students because you get to play with it and you can say, well, what would it have been if my service factor was less than 1.15? Or what if my temperature rise was over 40 degrees Celsius? Then you know to use 115% and you would have come up with a different value, at least for the overload protection. But you get to play around with it. So that's what's cool about it is just that's how you learn to be able to do it that way. Okay. All right. And then we did the branch circuit protection right here. Right. Is a circuit breaker. We did it at 59.4 amps times 250%. Right. And that was 149 amps. Basically, it was 148 point whatever over 0.5. So we rounded it to 149. So obviously that means it's going to go on to a 150 amp overcurrent protected device. That type of thing. Makes sense? Okay, and that's where you get right here. Next standard size. All right, so that's that one. Now let's look at the other side. So let's look at this one over here. Okay, so we've sized everything here. We feel good to that motor. Now we're coming over to this one. All right, same concepts. And we already know that this motor is what the amps are. It's 143. We already know what the overload is. So look, it's the same process. Nothing changes. The only difference in this scenario is that we have fuses, right? So when we're talking about fuses, all we have to do, and in our lesson, it tells you the type of fuse. So you don't have to worry about that. We always want to tell you whether it's just regular, simple fuse, one blow, one and done, delayed, whatever, always given in our examples. For you, it's going to be very much dependent on what type of fuse you're dealing with, right? So in our case here, let's go on and look at 430.52 again, because we're doing short circuit ground fault protection. So let me get to it here. Oh, by the way, this is why we stopped doing the lives on TikTok in the mornings, is because I couldn't share stuff with you. I couldn't share screens. You know, if you have any questions, you can always post your questions. I will answer your questions. So feel free to chime in. This is not a lesson where you just sit back. I mean, this is our morning show. So if you want to ask questions, or even if you draw me away from the topic, it's perfectly okay. It's not a problem. All right, so here's what we're dealing with here, okay? So we're dealing with fuses. So again, depending on the type of fuse, let me share the screen. So here is 430.52, whether it's 9-time delay or it's time delay, it all depends on the question, right? It all depends on what's being asked, and what is part of the lesson is like, it's up to whatever you want it to be. But in the real world, it's most certainly going to be based on what? It's going to be based on whatever you're using for your short circuit ground fault protection. Okay. So let's see here. So in our cases, we're going to be using the dual element time delay fuses, which is probably what you're going to see most of the time, is dual element time delay. All right. So when you come down to dual element time delay, and we're coming down to the same type motor, we see that good news here, all of these be 175. So we know that our motor is an AC polyphase motor. So it's 175. All right, no different than what we did before. It's just we use 250%. It's no different, right? So let's go back down here to our motor. Let me reduce the screen here so you can see a little bit more. Might be harder to see, but where we go. So all we're going to do is, so we're going to take the FLC to do this. So it's 143 was the FLC. Again, same concept as we did before. 143 times 1.75. And that is 250.25. Okay, well, we're going to drop the 0.25 and we're going to use 250 right here. Okay, boom. And that's why those are going to be 250 amp fuses. Okay. All right. So, so what you might say is, okay, do they make fuses that are that? So what we got to do is we got to go to, just to check to see 240.6, and we'll share here. And yes, so it goes from 225 to 50. We're dropping the 0.2 and we're going to use the 250 here because this is a maximum. The table 430.52 is a maximum, right? So we're going to drop it and do that. Okay. Let's go back to this lesson. So there's our 250 here. Now sizing the overloads, same concept here. We assume the same thing as we did before, the 125%. So we'll do the overloads is 131, the nameplate's 131, and we'll do that times 1.25, and that is 163.75, okay? And so we're looking at 0.75, we're rounding to 164, so we need overloads that are 164 amp overloads, okay? And as far as the conductors, same concept as we did before. We're doing them at what? 125%. That's in accordance with 430.22 because we're just doing this single set here, this single thing here. All right. So in that case, it's the FLC. So 143 times 1.25. That gives me 178.75. So we'll say 179 amps. And obviously, we're going to be in the 75-degree column. So let's go to the NEC. And we'll go to 310/16. Getting pretty easy now. Guys, if you got any comments, feel free to let me know in the comments. Anything you want me to explain, I'm more than happy to do so. It's your time. I want to make sure that I'm a good steward of your time as well in these coffee hours. So again, ask any questions you may have. I'm more than happy to answer. So here is our 3. So we need something that's 179 under the 75-degree. And of course, we assume copper unless stated otherwise, always. So it looks like we're down here. And let's see here. What are we at here under the 75? Let's see here. What could we get away with? Let's see here. Let's see here. Actually, we need 179. So, we just missed it here with the 2-aught, right? We just missed it with the 2-aught. So we have to go down to the 3-aught because that's good for 200. So we got a little bit extra headroom in there. We're definitely in the 75-degree column. We are definitely going to be over 1 gauge anyway, and we're also over 100 amps. We knew that from the start. Plus, we know that motors, it automatically will kick us into the 75-degree column for this motor that we're working with. Okay? So that's why we're in this one. So should be 3-aught. So let's go back here, and that's where the 3-aught comes from, right here. Okay, so all of this. Now, with all that said, let's get to what most people want to know. They say, okay, well, how do I size this? And how do I size this feeder? Okay, easy questions. So the first thing, since we know all the sizes here, the first thing we want to look at, let's go on and size this right here, just so we know the size we need. So we're going to be looking at where? We're going to be looking at 430.62 first. So let's go into the code. I'll take you to the code because we're sizing that feeder. So let's go here. Bear with me as I scroll through here. It's early. I still haven't finished my coffee yet. You got your coffee? Let me know where you're from again. If you haven't, let me know yet. And let me know if what's your beverage of choice in the morning. And please don't tell me it's a shot of moonshine, Ronbo. Come on now. All right, so let's go down here to 430.62. Okay, so here we're at 430.62. Now, it gives us some direction here, all right, for sizing that thing. It says, okay, it says a feeder supplying specific fixed motor loads and consisting of a conductor size in accordance with 430.24. We haven't done that yet, but that should give you a hint. That's where we're going to go for sizing that feeder. It says, shall be provided with protected device having a rating or setting. Now, here's important. It says setting not greater than the largest rating or setting of the branch circuit short circuit ground fault protection for any motor supplied by the feeder. Okay. Plus the sum of the full load currents of the other motors of the group. Okay. Now, if you happen to have two motors that are actually the same, you just take one of them and just assume that's the larger and go with your math. Okay. That's this language down here. So important here is not greater than. So remember when we were sizing the short circuit ground fault protection for the single set of motors that we saw that there was a note or there was an explanation underneath that says that if it doesn't correspond to, you go to the next standard size. Well, this is interesting because you don't do that with the feeder short circuit ground fault protection. Good news is they don't reinvent the wheel here. They're still going to send you back to the 430.52. Okay, so we're still going to be using that. So that's pretty straightforward. All right, so not greater than. That's the key thing. And you take what? You take the largest of the two motor strings. You take the largest short circuit ground fault protection, and then you take that, right? And then you multiply it by the percentage in 430.52, the table, and then you just take the sum of the other motor that's in the same group. Now, I have people that will ask me, what does that mean, the group thing? Well, obviously, this motor is connected to the same conductors as this motor. So they're in what's called the same group, okay? They're sharing the same conductors, okay? So you have motors that share a conductor. That means they're in the same group, okay? So these two motors are obviously in the same group, okay? All right, so you're able to move forward with this. So let's go on and look at here. So when we did our math and we looked at our protection, obviously we've got them, already here on the screen. So you've got this 250, right? So if you got the 250, that is your protection, right? You've already done the math. We already did the sizing for those fuses. And then you had the sum of the other, right? And that was 59.4. Okay? And that is 309.4 amps. You'll see how we got that? We did exactly what it says. This was the larger of the two short circuit ground fault protection. We took the larger, as it said, and we had already done this one. That's why we do all these strings. We've already done this one at the 175%, the same way that it says in 430.62. And we says you take the sum of the other motor that's in the group. All right, so this one's at 250 right here. We took that and we added the 59.4 amps to it. That gave us 309.4 amps. But what did it say back in 430.62? Okay. What did it say? It says, this shall not be greater. Okay, not greater. So that means you got to do what? You got to go down to the next standard size. So that's what makes it unique about the feeder versus it when you're doing these individuals units. So this right here gets dropped down to 300 because you can't go to the next standard size. You have to drop down. Okay, so that's why that is 300. Okay, now last piece we need to size of these conductors. How do the conductors get sized? All right, well, let's go on to the code again. And now, what did we say earlier? This is going to take us to 430.24 because that's where you have multiple motors. And it's not brain surgery. It's pretty simple. It says you take the FLC, okay, and you're getting this from where? You're getting this from the table, okay? In this case, 430.250. And it says you take the FLC of the highest rated motor, whichever one is higher, and then you take the sum of the other motors that are in the group. Well, we already explained what the group was, so that's a no-brainer for us. So let's go back to our example. All right, so highest motor. Well, we already see that this is the highest motor. I mean, this FLC is 143, right? And then this one over here is 59.4. So we're going to take this. So let's do this. We're going to do the 143 times 1.25, and that is 178.75. And then we're going to add the sum of the other motor because that's what it said to do. That's 59.4. So we'll take that plus 59.4. And that gives me 238.15 amps. Okay. So that's the amps that we need. Okay. For this right here. So this says a 250 kc mil. Let's see if that holds true. So let's go over to the NEC. Okay. And let's go to 310.16 again. And we're going to go to 310.16 in our code book. And we're obviously over 1 gauge. We're obviously over that. So let's go on and expand out here. And so we know we're in the 75. And again, no adjustment or corrections have been brought up. And that's going to be for another episode on Coffee Hour where I go over adjustment and corrections. So you're going to learn a lot in these coffee hours. But don't be afraid to ask questions. All right, so in here, I need a conductor that's good for 238.15 amps. We go down here, and oh, we just missed it with this 4-aught. We had to go down to the 250, and that is good for 255 amps. It can handle the 238 amps that we need, so that's why it is a 250. Okay, so we come back here. So that is why our conductor size is 250. Makes sense? All of this makes sense when you break it down piece by piece, and that's what we want to do. We want to make sure that we break these things down piece by piece, and that's what we're going to be doing. And I don't know anybody else that's going to do this or does this, but we're going to be doing this in the morning shows. But I'm also want you to remember that share it with your friends. Let people know that we're doing this morning show from 8 till 9. And it allows you to be able to answer your questions, get you some coffee, get you rolling in the morning. Let me know every morning where you're from. I love hearing from wherever you folks are from. If you have any trouble with the stream, let me know. I love the feedback. All you got to do is go to paulabernathy.com and give me feedback or put something in the comments. Always give us likes and shares and subscribe and let people know. I think what we're going to do is we're going to be doing this on our private channel, but we also will be doing this on YouTube. Hopefully some people just love following us on the YouTube channel. So that is one way that's one way to follow us. And I'm not going to add Facebook. I don't believe yet, unless anybody sends me something and says, Paul, I got to have it on Facebook. That type of thing. So, all right. So the floor is open. We've got a few minutes. I got about 5 minutes. I want to be good stewards of your hour. Has anybody got any questions on anything? Let me know what you got going on for your day. You know, cat's all crooked. But if you like this concept of the morning shows to get you going in the morning, let me know. and I was more than happy to answer any questions. Good morning, Phil. Thanks for joining me on this coffee hour in the mornings. Now, is there occasion where you may come in the morning and I'm not on? That means something happened. Most of y'all know that I'm, have a situation going on with my wife in the Alzheimer's early stages, and so I could get a slow start. But it is what it is. But for the most part, I like to get my day going. Encore hadn't started yet. They're still, they're an hour behind. So this allows me to have this morning to get ready, get all my stuff in order, and get set up to be able to have a great morning with you folks. And this is something that we said we wanted to do, and do little lessons, little mini lessons, and try to cover things. This was pretty big lesson. I mean, this is motors and this is multiple motors. And really, if you think about it, I showed you how to deal with the single motor application. So if you ever have a single motor, it's just that easy. But we also covered multiple motors this morning. And we covered how you would size the feeder to that application. Now, in future episodes, we'll get into other things like taps and all kinds of good stuff. But this lesson today actually was from our commercial wiring. So for anybody that asks what the hell's included in the commercial, look, it goes over motors step by step, talks about the little pieces. So it's a great companion course. It's 12-month access. And I helped write a lot of these in the 2020 edition. I did not do any of the writing in the 2023 edition. So they wised up and got rid of me. I guess that's what we should say. But I'm always here to help, and I will not be doing the lives on TikTok anymore. So they're going to be here. So if you follow me on TikTok, because not only the fact that they ban me for whatever I say, and they probably wouldn't for this because this is code, but it just irks me that they do that. That's why we want to get more people familiar with our private channel over on Fast Tracks Tube. So try that out. Tell me how you like it. It is a little bit of a delay on that end. I don't know if it's a delay on YouTube, but there's a little delay on that end. But it's just the way the system works. But hopefully you got something out of it. So good morning, everybody. Hopefully you get a good start to your day. And that's it. And I would say this is episode number 1 of our morning show of Coffee Hour. And hopefully you will you enjoy it, and you'll come back tomorrow. And you'll share it with people at your work, at your job site. You'll share it on your social media channels. You'll give us a thumbs up. You'll give us a like. You'll share it. And we'd love to have you spread it around to everybody. All right. So anybody else got any comments that you want to comment? And, good, bad, or the ugly. And we'd love to have you. Is this Electric Secret says yes. So this is the new, it's going to be every day unless, of course, I got to do something to tend to my wife. Okay. So yes, it's going to be every morning on YouTube, and try it out over on Fast Tracks Tube. There's a link in the navigation that says the live show. Try that out as well one day and let me know what your thoughts are on that platform as well. Oh, and by the way, before I go, if any of you want to join Fast Tracks Tube, it's an annual subscription for exclusive videos, 50% off. Just use the coupon code 50OFF, all caps, 50OFF at checkout, and you'll get 50% off. So you get like $49. And that also has an 8-hour webinar on calculations. That's worth it alone. Plus, it's got the entire series on pools and spas. Great investment. And if you don't like it in a year, you don't have to resubscribe, that type of thing. But we have a lot of series that are going to be starting over there as well. Okay, so anyway, check that out. All right, folks, that's all I've got this morning. Everybody have a wonderful day. Now I'm not going to send you a link, dude. It's really easy. Just go to YouTube. You're watching, wherever you're watching it now, you'll be able to watch it every day. Okay, all right. Later, folks. God bless.